2. Given an array of meeting time intervals. Intervals where intervals are values equals to the start and the end, return the minimum number of conference rooms required. So this is the start and this is the ending for this one and each one of these. So we see the output here. It says that we only need 2 rooms. So we can see that these two, hold on. We can see that but this one's easier to tell us because these two are in the range and inside. Wait, hold on. So this. So we're going to take the endings. We're going to sort these out by the start times. These are already sorted, and then go and put the ending inside of our heap, and then check if the starting of this one is greater than this, which is not, and we're going to hold on. If it's greater than or equals to the ending, which is not, so we have to make a new room. We have to put this inside the ending, make a new room and put this inside here. This is the ending, so now we have 2, and now we're going to move to this one and check if this is hold on, let me solve it. Let me just put so input if intervals, this is our edge case, if intervals, if not intervals, return 0. So this one's already sorted. This one is not sorted, so let's sort them out. So intervals dot sort key is equals to lambda x sort by the starting value. Sort by start times. So now let's make our min-heap list heap equals to 0, and then we're going to so now we're going to do heap q dot heap push min-heap dot cover and intervals, and then put 0, 1. So our ending value, which is our ending time for the first ending time. ending value of the first listed pushed first in our sorted list. So now let's make a loop iteration. So for I in the range of 1, so we already have 0, so 1 to the line of intervals, intervals. So if our starting value ends after ends for if our starting time, if our current starting time for our integer for interval is greater than or equals to our current the first value in our min-heap. Let's use that room since there is no collision. So that'll be done by so if intervals put I 0, is greater than or equals to greater than or equals to our min-heap, the first value, which is the one with the smallest start date. Heap Q reuse when it is heap push dot min hip hop min-heap. So the smallest end date. End time. Let's push the current end time anyways into our min-heap, and then we'll do heap q dot heap push, and then min-heap intervals I1 and return the length. This is what we have to return minimum of the current fast. Don't be quiet. min-heap that we have left. And let's see if we there's any syntax errors. Oops, I'll define one. Okay, now let's see if it's going to work. Intervals. Now what's the problem? Oh, forgot to do this. And it's been accepted for both of these cases. And our time and space complexities. The time complexity is O of n log n. We have to make our iteration, which is O of n, and then our heap functions, which is log n, and space complexity. Space complexity is O of n. The heap function. So then let's submit to see if it's going to pass all cases. And it says valid expected an integer. It hasn't been able to pass all cases. Oh yes, this should be outside. And let's submit now to see. And it's been accepted. And let's analyze our time space time completeness n of log n and our space complexity. Space complexity n of log n. And that's it for this problem.